Hello, students. Today we'll be working on Notes 14. We're going to be graphing piecewise functions. Those are functions that are made up of two separate definitions. So you could have lines or parabolas or other types of graphs, and they share the same grid. They will not be overlapping, and they may connect or they may not connect to each other. So you'll see that this is what the equations or the problems will look like. And so we're going to identify the two types of functions, and for our graphs, we've come up with the two types that we're going to look at. You'll either have linear functions, and for the linear functions, you can either have a positive slope or a negative slope or a horizontal line. And so for these first two, for a positive slope or a negative slope, your equation is going to be y equals mx plus b, and you'll be looking at the m for the slope, and if it's positive, then you choose linear positive slope or negative linear negative slope. And then for the other type of line, the third type would be a horizontal line. And in that case, then your equation would just be y equals a number. And then we're also going to include in this quadratics, and that's going to be where you have an x squared. So the quadratic will be in the shape of a parabola. Usually you'll just see part of it, and you would be looking for the x to have an exponent of 2. So when it says the function type, these are the 4 choices that you're going to have. Now we're going to have the graphs completed for you, and you'll be doing a matching. So you'll have problems where, like in this top example that we're not graphing, this f of x is like your y equals. So if we say y equals 3x plus 2, that would be like the mx plus b. So this one would be a linear with a positive slope. So I would choose linear positive slope on this. And then on the bottom one, I have y equals, and then I just have -1. And so for this one, it's just y equals a number. So just a number here, and that's going to be a horizontal function. So this is what we're talking about when we say for you to determine the type of function. And then even though we're going to have the graphs completed for you, you're going to need to know enough about what's going on to be able to choose the correct graph. So probably the biggest thing will be for you to know how to determine the starting value and whether or not you would be using a closed circle. So for this part of the graph on this problem, it has a greater than or equal to, so I'd be using a closed circle. And then this part of the graph, I have a less than without an equal to sign, and so I'd be using an open circle. So let's take a look at an actual example where we analyze it. So our problem is to graph the function f of x, which remember that's like your y equals. And then we have 2 parts here. So the top part is 2x plus 1. So I'm going to write that y equals 2x plus 1. And so the function type of my choices, I've got this y equals mx plus b. So I've got a line, so it's linear, and then the 2 is positive. So this is a linear function with a positive slope. So linear, positive slope. And so then I want to look at the x values that this is going to take on. Now, it says that x is supposed to be less than 0. So one thing that's true about this type of graph is this is a boundary, and the boundary is either going to be included or not included, but we do always want to start with the boundary as you analyze it. So even though it says x is less than 0, we want to include 0, and we'll have a way of graphing that so that it's not actually included in the graph. So less than 0, those kinds of numbers would be like -1 and -2 and -3 and so on. And so you could just type in this to Desmos and get some table values. If you have a table to fill out, that might be the easiest thing to do. In fact, let me go ahead and show you what that would look like. Now, this is not going to get you the graph that you see here. This is just to help you out with your table values. So remember, it's y equals 2x plus 1. And then you could go to the gear, get your table. And if you have to complete a table, remember we started with 0 and then -1 and -2 and -3. And if you had to keep going, you could. So you've got these y values of 1, -1, -3, -5, -7. So you could use those to fill in your table. So we've got 1, -1, -3, -5, and -7. Now, this is a less than, so when this part of the graph gets done, it's going to have an open circle. So what I want you to notice in your choices here is that this part of the graph has an open circle at 0, 1. So at 0, 1, we have an open circle. And then you want to see, are these points on this part of the graph? So when x is -1, is y -1? Yes. When x is -2, is y -3? And when x is -3, is the y -5? And so yes, it is. So this branch of the graph would be the y equals 2x plus 1. Notice that it's a line. It's going up as you look at it from left to right. So it is a positive slope graph. All right, so now we're going to look at our second graph. So on this second graph, this is y equals 3x minus 5. All right, now that also is mx plus b. And so this also is linear. And we're going to look at the slope. The slope is the 3, and it's positive. So this is linear again with a positive slope. So you would again be looking for a graph that had a line in the second part that went up. So notice that what I did in red here, this line is going up, and then I need to look for another line going up. All right, now this part of the graph starts at x is greater than or equal to 2. That would be its x values. X is greater than or equal to 2. So I want to start at that boundary and then go with numbers that are bigger than 2. So 3, 4, 5, and 6. And again, I can use Desmos to type in that part of the graph. So let me get a new graph. So it was y equals 3x minus 5. And again, remember that this is not the graph that you're seeing as an answer choice, because this is showing the whole graph where there's no restriction on the x's. But it does let us see what we would need for a table. So our table, we started at 2, and then bigger 3, and then 4, and then 5, and 6. So here we have 1, 4, 7, 10, and 13 as our y values. So we can fill those in the table. So 1, 4, 7, 10, and 13. Now, for this one, we had a greater than or equal to 2. So this point, this 2, 1, should be starting with a solid or a closed circle. And so you see this 2, 1, it does have a closed circle. And then you just want to make sure that you have these other points. So 3, 4 is on the graph. And I don't have the graph going all the way up to 7, but it does look like it would be headed in that direction. You could also check out the slope, that from one point to another, it used up 3 and right 1. So if you were choosing graphs, this one would be the graph that goes with the problem. Then you're asked to identify the domain and range. Now, we haven't done a lot of this, but that's really the important part of this type of graphing. So for the domain, now remember that the domain is your x's. You're going to, and I have the domain listed in interval form. So we haven't done a whole lot with this. A parentheses means that it's not included, and a bracket means that the boundary is included. So, and you can have, so you could have 2 parentheses where neither the beginning or the end is included, or you could have 2 brackets where both the beginning and the end are included, or you can have a mixture of the two. So those are the different types of notations that you'll see. If anytime you want to say that it goes on forever to the left or to the right, to the left would be negative infinity. And so if you were ever doing infinity, that one would be negative infinity. Infinity never has a bracket. It always uses a parentheses. And if it goes on forever to the right, then you would say positive infinity. So you could, those are the different types of things that you'll see as choices. So for the domain, you can take a look at these definitions. So this says the x is less than 0. So these numbers are less than 0 forever. So that means that on the smaller numbers than 0, that could go on till negative infinity, but it's going to stop at 0, just like it does here. It stops when the x is a 0. But that open circle and this less than sign, the 0 is not included. So we'll use a parentheses. Now we're going to use a little u, and that stands for union with, because we have a second part to this. So the second part to this says that we start at 2. We have this equal bar. We have this solid dot. So we want to include the 2. So we're going to include the 2. And then it says that it's greater than or equal to the 2. So from the 2, it goes on forever. So from 2 to infinity. Now, infinity always uses a parentheses. So this would be the domain. The domain is what's true about the x's. And oftentimes you can look at the problem set up to look at your domain. Now, the range, on the other hand, those are your y values. And the range you really need to get after you get the graph. So the domain, you're looking at your y values. I meant to use a different color. Or no, I guess I have the pink. For the range, you really want to look from the bottom up. Okay. So as you're looking at it, go from the bottom up. And so at the bottom of this graph, you see that this graph is continuing. It would continue on and on here. And as we go up, this graph is going to continue on and on here. So from the bottom up, we can see that it goes on to negative infinity. And then it looks like our graph stops when it gets up here to this 1 value because it has this open circle. But that's when this one takes over. And then it includes the 1 and goes on forever up. So this graph has a range that goes on forever from the bottom and goes on forever from the top. And there's no gap in between. Now, there's a gap for the x's, and that's what we've shown here. But as far as the y values go, once this one stops, this one takes over without a gap. So your range would be from negative infinity to positive infinity using the parentheses. So we will continue on and look at a second example that's got a couple of other different types of functions. So we have the function of f of x equals, and then your first one is x squared. So we have y equals the first one, x squared. And so since it has an x with an exponent, this is a quadratic. And the graph of a quadratic is a parabola. And the x values are supposed to start when x is less than or equal to -1. X is less than or equal to -1. So if we were making a table for this, we'd have -1, and then we want to go under that. So -2, -3, -4, and -5. And so let's go to Desmos and type that in. I'm going to remove the 2 graphs that I have. And so the first one is y equals x squared. And look at a table for it. And we'll remember that we start with -1. So we want to go -1 and then go smaller. So -2, -3. And you'll probably find that even though we've asked you to put these table values in, your graph probably doesn't include all of these. So we get 1, 4, 9, 16, and 25 as our table values for the y. So 1, 4, 9, 16, and 25. So we probably don't have all of those on here, but notice that I do have -1, 1, and that -1, 1, let's check and see if it's supposed to be a solid dot. It has that less than or equal to, so yes, this one is supposed to have the solid dot. So negative 1, 1. And then if I go to negative 2, 1, 2, 3, 4, should be a point that is showing. If I go to negative 3, 1, 2, 3, 4, 5, 6, 7, 8, and 9 would be a point, and then it would continue on up. All right, your second graph in this is y equals, and then notice that it's just the number 4. There's no x. So when it's just y equals a number, that's linear. But since there's no x, it is a horizontal line. So this is linear, horizontal. And these x's are supposed to start at negative 1 and be greater than negative 1. So going up from negative 1, we'd have 0, 1, 2, 3. Now, sometimes it's hard to understand how those horizontal lines work. So Desmos could help you out if you just type in y equals 4 and you check out a table for that. We were supposed to use negative 1 and then bigger. So negative 1 and then 0 and 1, 2, and 3. Well, I hope what you're noticing is that the y value doesn't change at all. It doesn't matter what those x's are. The y's stay at a 4. That's because that horizontal line happens because every single y is a 4. That's what that y equals 4 definition is. So all those y values are 4. And notice that it was greater than, so it did not have an equal bar, which means that that part of the graph should be an open circle at negative 1, 4. So at negative 1 and 4, we have an open circle. And then all these other points, 0, 4, and 1, 4, and 2, 4, and 3, 4, should be on the graph. So this graph will continue on in this direction, and this would be our, sorry about that, this would be our selection of a graph for this function. So the domain for this graph, we want to look at our x values. So domain is your x's, and it says the x is less than or equal to negative 1. So all the x's less than or equal to negative 1, that's going to keep going on to negative infinity. And then it says all the x's that are greater than negative 1. So if you think about that, and you can also kind of look at your graph, all the x's that are less than or equal to negative 1 are taken care of with this graph. And then this graph takes over, and all the x's that are greater than negative 1 are graphed here. And since we have a solid dot here, the negative 1 is included. And so when this graph takes over, the negative 1's already been taken care of. So actually, all the x's are used from negative infinity to positive infinity, and that would be your domain. There's no gap. Now, there's a break, but there's no x that is left out. The x's that are less than or equal to negative 1, they include that negative 1, and then they just keep right on going here. All right, so then we need to take a look at the range. So for the range, and again, these are your y values You want to look from the bottom up. All right, now on the y values, notice that neither one of these graphs are going to go below this blue dot right here. So we actually have a lowest point, and it's not negative infinity. In fact, remember, you want to look at the y values. So the lowest y value is this 1, and with the solid dot, it's included. So we want to use a bracket and use the 1. And then as we look going up, it looks like we should talk about what's going on here when y is, so this is 1, 2, 3, 4. It looks like we should talk about what's going on when y is a 4. But really, all that we're looking at with domain and range is what y values are covered by any part of the graph. And although this one does have y values of 4, this one keeps going up and has y values that are going to continue on and on and on. So the 4 really has nothing to do with it because it's not where the y value stops. The y values continue to go up, and so they go from 1 and go on forever to infinity. And so with infinity, we use that parentheses rather than the bracket. So this would be the type of analysis that you could do. I do want to show you on Desmos how to graph so that you can see this graph. If you can't figure out which graph to choose based on doing this, I want to show you on both examples how to type this in. So what you would do on Desmos to type this in, you actually start with the x part of this. So on Desmos, if I wanted to see the graph like what you have on your paper, you would type in y equals, and then you have to use a brace. And so that's on the shift, and it's right beside the letter P. So you get this brace, and it says x is less than 0. So I have to type that in. Make sure you're in the gray box there. So x, use your less than button, 0. And then you put a colon, and then you put the top function. So that would be 2x plus 1. So I would keep typing. You do have to make sure that your cursor has not moved. You need to be right by that colon. So 2x plus 1. Then you put a comma, and that tells you that you're finished with that first section. Then you go back, and now we do the x is greater than or equal to 2. So we're going to type that in. Be sure you're right beside the comma. So x, now you don't have a greater than or equal to button. So you do shift and get the greater than sign, and then hit the equal sign, and it'll put greater than or equal to for you. So it's greater than or equal to 2, put a colon, and then that part was 3x minus 5. So I want to keep typing. Make sure you're right by the colon, 3x minus 5, and then close the closing brace. Now, one thing that you will not be able to get that we have provided for you on your answer choices is whether or not it has a open circle or a filled in dot. And on some of the graphs, it will tell you, like I can go to right here and it'll say 0 undefined, and that means that there would be an open dot. But on Desmos, that does not always happen. So you have to, you're going to have to go by what your charts are telling you. Here, you can get to that 2, 1. But this would at least give you a picture of what the graph should look like as you make your graph choices. So once again, you type in y equals, you put in that first x part, then a colon, and then what the y would be. You put a comma, you put that second x part, a colon, and what the y would be. So there's how you would do the first one. I'll quickly show you the last one, just so you have a second chance to look at it. So for the second one, we start off with x is less than or equal to -1. So again, I type y equals the braces, and then x is, remember that to do less than or equal to, I have to hit the less than button, then the equals, and it will put the less than or equal to sign. It was x is less than or equal to -1, then a colon, and my graph was x squared. Remember, that's a shift 6 to get an exponent. Then you put a comma, and then x is greater than -1. Put a colon, and the rest of that graph was a 4. And then you have the end of the brace. So you can see that you have that parabola, and right here at the -1, see you have your -1, 1 showing. And then here you have, let's see if I can get it to do the -1. Now, this one's deceiving because this one says -1, 1, and yet one of those is an open circle. So that's what I was saying. Desmos is not always reliable. You will have to go by what is in your chart about which one should be a solid dot and which one should be the open dot. So this that I have with the big red circle about should be the open dot because this was a greater than sign, and you can see that it was an open dot in the one that we provided for you. So this would be your lesson for homework 14. You'll have graphs to choose from. You'll be asked to find the domain and range. Good luck with your homework.